I want to take a few minutes and talk to you about Solid Edge with Synchronous Technology and what makes it different than other CAD tools available on the market today. Most 3D CAD systems are using technology developed in the early 90s in what is called history-based modeling. In Solid Edge, it's known as ordered modeling. This is a paradigm in which features are based on top of each other. You start with a base feature and you begin adding more features to complete your model. If you want to make an edit, you have to roll the model back to that particular feature, make the change, and then all of those features have to be recalculated. This is really prone to failure because you can create dependencies that you didn't anticipate. So let's take a look at what synchronous technology does for us. So I'm going to start just by creating a rectangle. I'm just going to create it on this front plane. And if we look, I'm just drawing on that front plane. You can see it's in 2D. And if I decide I want to make this a 3D model, all I have to do is click on the region. I don't have to run any command. I just select an arrow and I can begin extruding this into space to create a 3D block. The other thing I could have done is click on that region and drag, this is what we call a steering wheel, to the edge of the model. I would pick the torus of the steering wheel and you can see that I begin to extrude this into a circular feature, a revolved feature. In my case, I want it to be a rectangle, I want it to be a block, so I'll just simply select it. Now, what I want you to watch is the dimensions. So I'm going to keep it centered, and as I drag this out, let's make it 100 wide. As I accept this, watch what happens to those dimensions. Those dimensions migrated from the 2D sketch directly onto the 3D model. So what that means, if I want to make a change to this, maybe I want this to be 60 millimeters tall, I can just key in the value and it drives the 3D model directly. Same thing here. Maybe I want to make this only 50 millimeters wide. So you can see that I'm modifying the dimensions on the block itself, not on the 2D sketch. The other way I can edit this is to actually just select one of the faces and begin to drag with the arrow. Notice how the part is staying symmetric. We have a proprietary tool in the upper right corner called Design Intent Manager. It's managing the design intent that we have developed in the model. Because I built this model symmetric about the base coordinate system, it assumes we want to maintain that symmetry and it keeps it for us. If we don't want it, we can simply uncheck it and move just the face that we selected. But in this case, I do want to keep it symmetric, and maybe I'll just pull this out 20, which is going to make it 40 millimeters wider because it's going 20 in each direction. Alright, so just to prove to you that we're not going back to the sketch, I'm going to show you the original sketch. You can see there's the original size of the block that we created. As a matter of fact, we don't even need that sketch, we can delete it. If you try to do this in any other CAD system, you just lost your extrude because it is based on that sketch and you have to edit the sketch to change the block. The premise of synchronous technology is that all of the intelligence is in the solid, the size and the shape. If you want to modify it, modify the solid directly. Alright, so we did a sketch on a plane. What if we want to sketch directly on the face of a part? Simply highlight the face that I want to draw on, click the F3 key, and now I'm locked onto that face. I'm just going to draw a line across the face. Once I have that drawn, you can see that that splits this into two regions. If I select a region and I pick the arrow, if I push it down into the part, it's cutting away material. If I pull it above the part, it's adding material. And I'm just going to drag this upward 150. Now, if you think about how we built this model, my first extrude was in the Y direction. My next extrude was in the Z direction for this vertical section. But what if later my design intent changes and I want this vertical section tipped 15 degrees? That's difficult in an ordered model because that was built as an extrude in the Z direction. I can't extrude at 15 degrees. So one way to fix this in other models is to cut this off and draw it from the side view at the 15 degrees. Solid Edge, you don't have to do that. We don't care how the model was created. You simply select what you want to change. If I pick on this arrow, I can make it shorter or I can make it longer. If I click this arrow, I can make it taller, I can make it shorter. If I move the steering wheel to this corner, I can rotate about that corner by clicking on the torus of the steering wheel, and I can rotate that vertical section however I want to. Again, I don't care how the model was built. Synchronous Technology is proprietary to Siemens software. You're only going to find this in Solid Edge. And just to recap, some great things about Synchronous Technology. Again, you don't have to worry about the downstream features breaking when you make a modification. You never have to roll the model back to some previous feature to make a change. You simply select the faces that you want to change, or the dimensions that you want to change, or add a dimension somewhere that you want to make a change, and you modify the model directly. Never have to worry about breaking those downstream features that are so time consuming to try and fix. So I hope you'll give Solid Edge with Synchronous Technology a try today.